Hello viewers, welcome to our session on Dbscan clustering in machine learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. Firstly, let us look at the definition of Dbscan. Dbscan stands for density-based spatial clustering of application with noise. It is nothing but a clustering method that is used in machine learning to separate clusters of higher density from clusters of lower density. Let's have a quick look at its picture. So let's quickly recap the key terms of Dbscan. The very first one is epsilon. It defines the neighborhood around a particular object. That is, if the distance between 2 points is lower or equal to epsilon, then they are considered as neighbors. If the epsilon value is chosen too small, then large part of the data will be considered as outlier. And on the other hand, if it is chosen very large, then the clusters will merge and majority of the data points will be in the same cluster. So, one of the best way to find the epsilon value is based on the k distance graph. When it comes to its min points, it stands for minimum number of neighbors data points within a epsilon radius. Larger the data set, the larger the value of minimum points must be chosen. As a general rule, the minimum points can be derived from a number of dimension d in the dataset, as minimum points should be greater than or equal to d plus 1. And the minimum value of the minimum points must be chosen at least 3. So there are 3 types of data points in Dbscan. These are core point, border point and noise or outlier. Let's have its picture also alongside with us so that we can understand it in a much simpler way. Any data point is said to be a core point if it has more than minimum points within its epsilon value. So here you can see that the green object is a core object. This is because it has satisfied the minimum criteria of 4 points. Since within the epsilon range, it is having 1, 2, 3, 4 and 5 points, and it has exceeded the minimum points range, so hence it's a core point. But then what is border point? A point which has fewer than the min points within its epsilon range, but it is the neighborhood of a core point, then it is a border point. So here consider this blue point. It is a neighborhood of the core point, but when we consider it's within its epsilon value, it doesn't satisfy the minimum points criteria, and hence it's a border point. And the left one is a noise. So what is noise? It is nothing but a data point or an object which is not a core point or neither a border point. And here you can see it clearly. Moreover, when we compare Dbscan with k-means, then you can clearly see the upper hand of Dbscan. It overcomes the drawbacks of k-means. Let us suppose we are having a dataset in this form. Then you can see Dbscan gives a logical clustering of our dataset. Whereas when you apply the k-means, you can see that it is something illogical. It's not clustering them on the basis of density, but on the basis of their distance. Whereas, moreover, in some kind of datasets, we can get only 2, you can see here that we can get only a fewer number of clusters, but k-means gives always a large number of clusters without any logical sequence. And finally, now it's time for your favorite hands-on session on Dbscan clustering in Python. So for today's hands-on session also, we are going to take the same data set that we have been dealing in k-means and hierarchical clustering. We need to cluster the customers who are on the basis of the annual income and civil score. You can see here. That's why first I am selecting the required columns. Further, we have to make sure that column 1, index 1 and index 2 column wise is selected and stored. That's why I am creating that array. See, it has been successfully executed, and you can see here I have got the age and civil score, annual income and civil score. annual income and civil score. So now since there is a huge difference between both the values 16 and 77 like this, so I would like to marginalize them and bring them back down to -1 and 1 through feature scaling. See, it has been executed successfully. Now its value has been turned and it has been transformed. Okay. So first, on the basis of, I would like to know what should be the approximate epsilon value. So for that, from sklearn, and it's the same of k neighbors algorithm. From sklearn package, I'm taking neighbors module and importing nearest neighbors class and created a neighbors object and passed the values, and I want to make the n neighbors as 3, and then I'm doing fit and transform. Let me execute this first. See, it has been successfully executed. Here the n neighbors means I am expecting at least 3 minimum points should be there in the minimum neighbors. Okay, after that I would like to plot the elbow curve to know the epsilon value. For that, I am from neighbors object, I am passing this x, what we are having, the transformed annual income and that thing. We are passing it to k neighbors and getting the distances of each of them according to their indices. Let me execute this chunk of code so that you can understand what I am saying. And after getting the distances, see, I have got the distances and their indices accordingly. And after that, of each of the plotting, after plotting them, now I am going to first sort the distances in the descending order. So let me execute this chunk of code. Now it has been successfully executed. You can check here. It has been successfully sorted in descending order. And now I am going to plot my indices and their distances in order to get the epsilon value. So here we have got the elbow curve, and from here you can make out that it's somewhere here at 0.3 should be the epsilon value, because after that it's almost changed drastically. So because of that reason, now here it comes our main implementation of Dbscan algorithm. From sklearn module, from sklearn package, I am taking cluster module and importing Dbscan class and created an object Dbsc for Dbscan and passed the two parameters of Dbscan were epsilon and minimum sample. So that's why I have created the epsilon as 0.3 from here and set minimum samples equal to 5, and then I am fitting it. Let me execute this chunk of code first. See, it has been successfully executed, and now I would like to know how many clusters have been formed. For that, I am creating a cluster object and storing all the labels. Let's see. See, it has been successfully executed, and the maximum value, I guess, is 3 till now. 4, 5, 6. Yeah, I can see the 6 are there. So it has formed 6 clusters. From 0 to 6 means 7 clusters are there in total. And this -1 represents the noisy data that doesn't belong to any of the clusters. It is -1. After that, I am going to mask my core samples. For that, firstly, in order to know the core samples, what I am doing is I am telling that all the samples, all the objects are not a core object. So I am setting them as false. You can see core sample has been masked and everything is set to false. Now I would like to know what all are the core sample indices. For that, we have this function Dbscan of core sample and storing this in y. See, it has been successfully executed. Yeah, indices of the core sample objects. So, okay, out of 200 dataset, these are the core sample objects. And after that, wherever we are getting the index, I am setting this as true. So it has been successfully executed. Now what I am doing is, let me show you through this. Core samples mask has been changed successfully. I have segregated the true and false. All the trues are the core samples, and false are not the core sample ones. Okay, let me check the total number of clusters that we have found, and we have already seen that it is 0 to 6 means 7 clusters are there, and -1 is a noise. So let me first change this cluster into a set. So it has been successfully executed. You can see what are the different clusters, 0 to 6 and -1. So the length of this cluster is 8 obviously. Let me show you here. Yeah, it is 8. Then what I am doing is number of clusters. The negative, I don't want the noise to be considered in the cluster. That's why I am subtracting 1 in the total number of clusters and getting the total number of clusters. And total number of clusters is in n clusters, and you can say its value is 7 as we have discussed. Now I am converting the cluster into a list and counting how many -1 are there, means how many noise objects are there. It has been successfully executed and stored in n noise, and you can see here 35 noisy objects are there out of 200 data points. So let me just print it. The estimated number of clusters and noise are 7 and 35. And now let us have a look at its visualization so that you can understand how Dbscan has effectively clustered the objects. Further, from the visualization, we are as usual using matplotlib and pyplot and using the alias as pld. Now first here I am marking this every cluster as a unique labels. Let me execute it step by step. Now let me explain you how the visualization works. I have marked all the unique labels. It will store all from 0 to -1, all the 8 values. Let me execute chunk of code. You can see it is in unique labels. Yeah, these are the unique labels 0 to 6 and -1, and I want each of the labels to be colored a different. So for that, from the matplot library, I am using color matrix and spectral for each in NP line space. I am assigning a different color. See, it has been successfully executed. Let me execute this chunk of code at once. Okay, it has been successfully executed. Now what I want to do is, for each of the cluster, for every object I want to color, and when it is a core sample mask, then it will be colored with the size of 14. Marker size will be 14. But when it's not a core sample, then its marker size will be 6 within a cluster. And if we are having any, in the first only we are checking, if we are having any noisy object, then we are going to bring that as black. So let me execute this chunk of code so that you can analyze what I am saying. So it has been successfully executed and we have got these clusters. And the black one represents the noisy variables, which means they do not belong to any of the clusters. As usual, I have included code snippet for your fast revision, so you can pause your video right here and can take the screenshot of the same for your future reference. I hope this video proved fruitful to you and hope you have gained something extra than what you were knowing earlier. Thank you.